Welcome to qnawire.
This problem contains a pulley, and then on one side of the pulley, there is the mass of the bricks, and then on the other side of the pulley, there is the mass of the counterweight. Part A asks us to draw free body diagrams of both, and so if we start with the bricks, which I'm just going to label by B here, then we have a force up, which is the tension of the rope, and then we have a force down, which is due to the gravity. So it's mass of bricks times G. So positive will be indicated by upward. So this is positive Y. Now for the counterweight, it'll look sort of the same. We have tension up, and we have mass of the counterweight times G down. And so these are the force diagrams or the free body diagrams for the two weights. Now for part B, we have to apply Newton's second law in the y direction for both of them. If I apply it for the bricks first, I get the sum of the forces in the y direction is equal to the mass times the acceleration in the y direction. This implies that tension minus mass of the bricks times G, minus because this force is downward in the negative y direction, is equal to mass of the bricks times A. And this term is positive because the acceleration of the bricks is upward in the positive direction. This implies that tension is equal to mass of the bricks times A plus G. Now let's set that aside and do Newton's second law for the counterweight. So in this case, this is just Newton's second law. And now when we apply it to the counterweight, we get T is positive, mass of the counterweight times G is negative, and this is equal to the mass of the counterweight times the acceleration. But in this case, it's equal to negative A because the counterweight's accelerating in the negative direction, but the magnitude of the acceleration is the same as the magnitude of the acceleration of the bricks. And so we get that. Plugging in the tension we found here into here, we get mass of the bricks times A plus G minus mass of the counterweight times G is equal to negative mass of the counterweight times A. Now, solving this for the acceleration, I get mass of the counterweight times G minus mass of the bricks times G over mass of the bricks plus mass of the counterweight. And then when I plug in all of these values, which are given in the problem, I get an acceleration of 2.96 meters per second squared. Now that's the answer to part B. Part C is asking us for the tension in the rope, and we can use a form that we found earlier in part B, the beginning of part B. We're going to use this right here. And so it's equal to mass of the bricks times A plus G. G for this problem we set to be positive, and we found for the bricks A is also positive. And so when we plug in all these values, we get 191.4 newtons. The last part of this problem asks us how this tension compares with the weight of the bricks and the weight of the counterweight. So if you do weight of the bricks is equal to mass of the bricks times G, you get a value that's less than this. I didn't actually crunch the numbers there, but the mass of the bricks times the gravity will yield a number less than this. And the weight of the counterweight is the mass of the counterweight times G. And this will yield a value greater than this. And so the magnitude of the tension is in between the weight of the bricks and the weight of the counterweight. And that's the final